All right, exponential functions. So first thing is your exponential form is a function that has the variable x, which we usually use up in the exponent. Couple restrictions on that. The base it's being raised to has to be positive, but it cannot equal 1. So what that translates to, if it's got to be positive but not 1, your base is either going to be somewhere between 0 and 1, or it's going to be bigger than 1. All right, first thing we want to do is looking at how to just substitute values in. So for A, find f of -1 if f of x is 2 times e to the x. E is a button on your calculator. It's going to depend on which calculator you have, but there should be, you're looking for that little print just like that. So when we say f of -1, and sub in -1 for x, so that'd be 2 times e to the -1. Go to your calculator and you're looking for your e button. Make sure you get it to the -1 power, and it's going to tell us, let's see, we were told to round to 3 decimal places, so it is 0.73, it's 57, so that would be 736. Make sure you're very careful with your rounding rules here. All right, the next one. Find f of 3 if f of x is 3 times 2/3 to the x. So we're plugging in 3 for x. 3's everywhere. Notice that 2/3 is in parentheses. Make sure you keep that base in parentheses so it comes out correctly. So we go calculator it. So with this one, you may very well, you could be asked for fraction form. So the fraction form would be 8/9. So again, read the directions carefully. And because it does say to round to 3 decimal places here, I'm going to go ahead and go to that. So this one will be 0. It's 8 repeating. So 889 would be our 3 decimal rounding answer. All right. Next, we're going to go into graphing. So here's just an example of what all of these functions look like, all exponential functions look like in different forms. So it's important to note the left side versus the right side, the difference in the graphs. You've got some increasing, some decreasing. Everything on this side has a base bigger than 1. Everything on the left side has a base between 0 and 1. So that's going to change how the starting point looks. All exponential functions level off or go flat at a horizontal asymptote. So all of these, because they have not been shifted around, all of these horizontal asymptotes are going to be at y equals 0, but we'll go over in just a second how to figure out where your function is going to level off. So I got that drawn in. Let me get back off my dashes. So they level off, level, if I can spell correctly. And the reason they all level off at y equals 0 is because there's something called a horizontal asymptote here. Just note the difference on which side it's going to level off. So it's going to depend on what that base was and what transformations are going to occur. All right, so here's your standard transformation form for exponential functions. We'll have to figure out what the transformations are, and then important characteristics for finding your level off point is going to be that d. So your exponential function levels off at wherever d is. Remember, d is your vertical shift up or down. So if you need to review your transformations, it is in section 7.2 if you kind of need a refresher on them. All right, so we're going to sketch the graph of the exponential function below. First thing I'm going to do is I want to move that 2 to the back because there's a lot of stuff going on here. I think it was F, yeah. All right, so first thing we want to note is our transformation. So just kind of as a review real quick, the negative out front, that's on the A value. So that's a reflection on the x-axis. So I'm just going to draw arrows to each. So this is going to reflect it across the x-axis. Or I guess actually before we get into those, it would help to know what the parent function was. So you're looking at your base right here. So we're going to backtrack for a second. Base is e. So that's your parent function, e to the x. And since E is greater than 1, this is going to be increasing from left to right because we have a base bigger than 1. So we know our original function was going up. However, because it was reflected across the x-axis, graph is going to be below. So what we had was a graph increasing, which looks like this. Now, because we have reflected it across the x-axis, the graph is now going to be below that mirror image. Next, we're going to go to this one here. This is a negative up in the exponent. That is corresponding to B. When B is negative, that is a reflection on the y-axis. So not from the original function, it's from the reflection we've already had. So we're going to take this graph here, that reflection on the reflection on the x-axis, and we are now going to fold it over the y-axis. So we're going to get a shape that looks something like this. And then our last transformation, and I'm going to all over the place on these labelings here, is going to be this 2. That 2 is going to be your vertical shift up. I guess we'll put the word shift in there. Up 2. So what that means for our graph, it is going to level off at y equals 2. So on the online homework, you won't be drawing the level off point in, but for the notes, I am going to draw it in just because it makes it easier for you to see where it's leveling off at. So here's our graph. All right, so the leveling off at y equals 2. Here's going to be, that's a terrible line. Let me change. Make it dashed, make it pretty. I like things to be pretty. So again, on the online homework, it's not going to draw this in, but for the notes, it's helpful for you to see this value. So that's why I'm going to do it. So here's our y equals 2. So I know this function has to level off there. Now remember, we were increasing. We reflected across the x-axis, so the graph is going to be below this line. And then we reflected across the y-axis. So instead of leveling off on the right side like it does here on the parent function, it's going to level off on the left side, which is going to be over here on the right. So we're going to get a function that looks something like this. Okay. So we took the parent function, which was increasing above this level off point, because the level off point is like right here when it's increasing. We then reflected it across the x-axis, so now it's below that level off point. And then we had to reflect it across the y-axis, so the ends have shifted along that level off point. All right. So, and then there's your kind of reminders for sketching that graph. You want to make sure it's in the right form. So that's where, notice I took that 2 that was originally on the front and moved it to the back. Then I needed to identify the parent function so that you know that base, whether it's starting off going up or starting off going down. And then use your transformations to adjust the graph as needed. Next one. Describe how the graph can be obtained and then sketch the graph. So that's what we are just looked at. So we're going to look at it again. So first thing I want is it is in the right format. So we need to pull our base. Our base here is at 2. So parent function would be 2 to the x. The base is 2, which is bigger than 1. So we're going to be increasing. So again, if it helps, give yourself just like a little paper visual. So here is an increasing function relative to that level off point. All right, we then, oops, hold on. Nothing out front, but we have this 8 up here in the exponent. That is addition, subtraction. So remember, that is your left or right shift. Minus right plus left. So we're going to shift left 8 units. Then we have, so as far as the graph, it's just going to shift over to the left 8 units. Then we have this one at the back, plus 5. It's going to be our up 5 units, so shift up 5 units. This one helps us sketch the graph a little bit more, so this means our graph is going to level off at y equals 5. So we don't need to change the shape of anything about mirroring it upside down or anything. We just need to go find our level off point and get it drawn. So, like I said, I'm going to draw that value because it is helpful. So those are just my x and y axis. So 1, 2, 3, 4, here's 5. I'm going to draw my level off point. All right. And actually, I'm going to move that down some. All right, 1, 2, 3, 4, here's 5. So that's where we're going to level off. We are keeping the same shape because there was no upside down, there was no fold over the y-axis, anything. So we're just going to copy the shape that we had up there relative to where our level off point is. So we're just going to swing up like that. And again, remember, your online homework is not going to draw that level off value, but it's the same idea as just look for making sure you're leveling off at the right value when you're trying to find the correct graph. All right, next one. We've got our base is E. So parent is e to the x, which means we would also be going up because it is bigger than 1. So remember, this means our graph is going to be increasing. So relative to wherever we are leveling off at, so I'll go ahead and draw that. We're swinging up. Now we need to go get our transformations figured out. All right, so first thing we have is a negative here. That negative is in the exponent, so that is reflecting across the y-axis. So what that means for our graph is it's going to go opposite what we see. It's not being folded down. Folded down is the x-axis. So we're going to switch. We'll call it switch ends. So the level off end is going to change. So for ours, here's our level off point. Instead of leveling off on the left like the one we see up there, ours is actually going to level off on the right side. So instead of increasing, it's now decreasing because of that transformation. The next one, that 0.04, so I'll bring it over here. So for this one, we are going to, that's your horizontal stretch or compression, and remember it's opposite what you see, what am I trying to say? What you see when it's out front. So if it's A, that's your vertical stretch or compression, and when it's bigger than 1, it's a stretch, and when it's between 0 and 1, it's a compression. But for this one, it's opposite. So this is your horizontal. When it's between 0 and 1, it is a stretch. So it's going to be a horizontal stretch because that factor on your exponent is 0.4. So the reason it's a horizontal stretch, I'm just going to put a shortcut because the factor in the exponent is 0.4. 0.4 is between 0 and 1. So if that would have, instead of 0.4, if that would have been just a whole 2, then it would be a horizontal compression because the factor would be a 2, which is bigger than 1. All right, so graphing, again, I'm going to draw my XY axis. And as far as graphing goes, you're not going to have a super big issue locating this graph. It would just kind of plotting points is what we would do in the online homework. So let's see, where are we leveling off? I need to make sure I'm leveling off at, so 0, because there's no up or down. So we're going to level off at 0. So I'm going to draw this in for you. So in your online homework, make sure the graph you draw is leveling off at y equals 0. And then we said the graph is switching ends because it was reflected across the y-axis. So ours is going to look something like this. And so, and to use that graphing tool to get that equation graphed, just plot some points to help you get it in the right spot. Next, we have our compound interest. So compound interest formula is on your formula chart. This deals with, money, how it can be compounded. Everything's labeled up here in your formula. So just pay attention to what goes in for what place. All right, first one, suppose you have $105 invested at 3.5% interest compounded semi-annually. First thing we want to do is write a function for the amount in your account after t years. So we're going to call it a of t, since that's what the formula calls it. All right, so P is the initial amount in the account. So that's our P. R is the interest rate in decimal form. So be careful with that, not 3.5, 0.035. N is the rate at which it's being compounded. So we are doing that semi-annually, which means 2. And then t years. So the initial model, we leave t at t. So our model is going to be 105,000 times 1 plus our rate, 0.035, divided by 2, raised to the power 2t. So getting all your variables plugged into the correct spots. All right, now that we have a model, I don't like where that is. I'd like it to be over here, and it's a little crooked. Oh, it's not gonna, whatever. It's just gonna stay crooked. It won't let me straighten it. Okay, we'll leave it crooked. God, I can't. That looks terrible. Straighten my division bar, and then it'll be a little bit better. Okay. All right, then it says find the amount of money in the account after 3 years. So after 3 years, time, this right here is telling us that t equals 5. I guess I can get rid of my dashes now. Not 5, 3. Where did I get 5? So we're being asked to plug in 3 for t and then simplify. So a of 3, that's the wrong color, I like it in blue. 105,000. 1 plus 0.035 over 2 raised to the 2 times 3. So notice when I plugged this in, I left everything exactly as is. You do not want to do any rounding until you are finished. So use your fraction template to very, very carefully get this typed into your calculator. And because this is money, we're going to answer to rounded to 2 decimal places. So the amount in the account is in dollars. It's going to be $116,518, and it's 747. So that would round to 75. So just be careful getting that typed in. Don't want any rounding until you're done. Next one. All right, the exponential function d of t gives the number of bachelor's degrees d of t in thousands earned in the United States t years after 1970. So this time we're given a model, we're not asked to create it. Find the number of bachelor's degrees earned in the year 1980. So again, word problems, words are important. The year 1980 does not mean t equals 1980 because t is the number of years since 1970. So this is actually t equals 10. So we're being asked to plug in 10 for t. So our model, 347 times 1.024. Oh, I'm running out of room. Scooch to the 10th. So we go to our calculator, and because it's not money, I'm just going to write down what the calculator gives me, and then we'll go over the answer. 439 point, it's 874, and there's some other numbers. I'm just going to leave it like that for a second. All right, if we go reread, it says round to the nearest whole degree. So remember, y, our DFT, is in thousand, so we're asked to round to the nearest whole degree. That is not going to be 440. Remember, this is in thousands, so what we would have to do is multiply that by 1,000. So we're going to take our 439.874, whatever it was, and we are going to multiply by 1,000 because our data is in thousands, and that is going to give us 439.874.7. Then we are going to round to the nearest whole degree. So that would be 439,875 degrees. So be really careful with the rounding here. You don't want to round to the wrong place. Let me move that out of the way for the next part. Oh, come on. Scoochie. Oh, there we go. So be careful. Round to the nearest whole degree. Multiply by 1,000 first. Then we can round to the nearest whole degree. All right. B. Estimate the number of bachelor degrees that will be earned in the year 2025. So T is not 2025. T is the number of years since 1970. So these are a little bit further apart. So if you struggle with that, that means we just take the current year minus the year it started, and we get 55. So we're doing D of 55. So D of 55. 347 times 1.024 to the now 55. And again, I'm going to write down what the calculator gives me, and then we'll go over how to answer. 1278.872 and some stuff. All right, now we're going to go reread. So this says round to the nearest 1,000 degrees. So notice the difference. Round to the nearest whole degree was part A. So we had to multiply by 1,000 first and then round accordingly. This one says the nearest 1,000. So that means we are going to go and round right away. So the number of degrees we would have 1279,000 degrees. Or you could choose to multiply it by 1,000. So take the 1279 and go ahead and multiply by 1,000 to get your number. So 1279,000 would put the 3 zeros on the back, and then you could just put the word degrees. So just read carefully so you know which way you type it in. If it's already got the word 1,000 in the online, make sure you don't accidentally multiply by 1,000. If it doesn't, if it just says degrees, you got to get those zeros at the back. All right. The rest are you try it, so you can go try those and then check them with the filled out notes posted online.